how the PpPpk is different from CP and CPK. Now take a closer look on the definition. Formula wise, it looks same. USL minus LSL divided by 6 sigma. But the sigma wise, it is different. Now what is written here in the place of sigma?
Overall.
Sigma
So the
overall.
big picture. Yeah.
So earlier it was sigma within, but now it is sigma overall. That's the main difference.
So
Even
that's
here also,
sir, that's for the particular range. This is the from the overall process, right?
no, I'll see. Always, remember the point. Seek to understand before being understood, right? So when you want to say what is what is within and then what is overall, we have to understand the context, how the process is going on. If you know how the process is going on, then you will be able to define what is within and then what is overall. So maybe once we go through an example, it will be clear for you. Now, capability depends on variation and then position of the center. Hope all of you know this. And accordingly, we have two types of capability. One is short-term capability, another one is long-term capability. The short-term capability or CP/CPK and long-term capability or PpPpk. Now, in order to calculate the short-term capability, you have to use the right standard deviation. For long-term capability, you have to use the right standard deviation, which is here for PpPpk or long-term capability, you need to use overall standard deviation. And for CP/CPK, there are three types of standard deviation possible. At this stage, I want you to understand the within enough. Right? Use only within standard deviation. And so your capability will be known as within capability. The other standard deviation, if you use between, then your capability will be known as between capability. If you combine the two, that will be combined capability, also known as within between capability. So how many capabilities are here? Within capability, between capability, and then there is something called within between capability, and then finally overall capability. Can all of you see here 4 types of capability? Yes or no? I am
Yes, sir. Yes,
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 sir.
yes.
Yes.
I am explaining this only to let you understand, know this as well as understand this, right? Gradually you can master, no issues. But right now, very important is you should know at least the difference between overall and within, right? Now, say imagine a scenario where you are the plant head. Hope this position is very common in many companies, right? Particularly again in the manufacturing company, plant head. So for a plant head, which capability is very important?
Sir, overall capability is very important.
Overall capability is important. Now the same plant is running in 3 shifts. Shift number 1, shift number 2, shift number 3. And for shift number 1, there is a manager, quality manager for shift 1, another quality manager for shift 2, another quality manager for shift 3. All the 3 shift manager will be reporting to the plant head. When the plant head is responsible for the overall capability, then what is the responsibility of the shift manager?
Within capability, sir.
Within the shift, everything that is happening, they are responsible for, isn't it? Now, as a plant head, it is also important for you to maintain consistency across the shift, isn't it? Whatever happening in shift number 1, you want the same thing to happen in shift number 2 also. You want the same thing happening in shift number 3 also. You can't say, sir, shift 3 is night shift, so there will be a lot of problem. No, I want the same consistency. That means you need within capability, you also need between capability. If you maintain within capability, also maintain between capability, then overall capability will get maintained. All of you are able to connect here?
Yes, sir.
Now the within, between and overall I explained with respect to the shift. Similarly, you can apply this depending on the requirement. Say for example, in the black belt training program, How many sessions you have attended? 6 days your training you are attending, isn't it?
Yes, sir.
Every day you must understand. Day number 1 also your understanding, should be great. We should have a capability there. And within a day also there is forenoon, there is afternoon. But within capability is a big problem here. Whatever, the way the session is going on in the morning, the same way it cannot go in the afternoon. So we need to, do something to balance it. So always depending on the scenario, the within capability and between capability comes into picture. And finally, the overall capability. What is overall capability? Ultimately, what's happening? Whether all the black belts are coming out successfully, are they qualifying? Are they able to practice? That's overall capability, right? But overall capability is the result of your within capability on every single day. All right. So with that, if we take some example, it will be very, very crystal clear. And when to use PpPpk? When to use CPCPK? So PpPpk you can use, first of all, see here, you can conduct the capability analysis only when the process is in statistical control. All of you, do you know what is statistical control? Have you used the word?
When there are only normal variations in the process.
Very good, beautiful. That means you discussed something about control chart, all of you? Have you discussed anything about control chart?
Yes, sir.
Yes, sir.
What is the control chart you discussed? X bar R chart?
Yeah.
Very good. If the control chart is under control, I mean, if all the points are seen inside the control limit, the process is considered statistical control. When a process is in a state of statistical control, only then you all should conduct capability analysis. Otherwise, please don't conduct capability analysis. All of you think my suggestion is meaningful?
Yes, sir.
Yeah. If the process is not in a state of statistical control, still you conduct the capability analysis, it is as good as conducting an examination for a student who is very irregular to the classes. Do you understand the consequence? If a student is very, very irregular to the class, it is quite obvious that he will fail the exam, isn't it?
Yes, sir.
Then what is the point of conducting the exam? Rather, you can make him to attend the class. After that only, you should conduct the exam. If you don't do this, your exam will not have any meaning. Suppose if a student did not participate well in the program, but still he somehow, managed to get the pass mark. What does it mean, the pass mark? It's not giving a real interpretation, isn't it? The interpretation is not real. Somehow he got pass mark, it doesn't mean that, he studied well. So to avoid all these conclusions, it is always recommended that you conduct the capability analysis only after ensuring that your process is under the state of statistical control, right? If the process is not in a state of statistical control, avoid conducting the capability analysis. I know it is difficult for you to practice this principle in a real life, isn't it? Your boss wants the CPCPK report. You have to give it. You can't tell him, sir, control chart is out of control. But you should know your limitation. You prepare the CPCPK report, but write terms and conditions. Or write some assumptions. Like every time you buy a credit card, you sign a document, right? Terms and condition. Without even knowing you are signing. Likewise, when you prepare a report, capability report, you have to write down your assumptions. What are your assumptions? It is assumed that the process is under statistical control. But reality, God only knows. Clear? And the calculations are based on 1 week study. All of you understand? And samples are collected in this manner. In this condition, this is the capability report. This is the best way of, conducting the capability analysis and generating the report. Otherwise, sometimes people may misunderstand your report. All of you are with me on this?
Yes, sir.
Very good. Now, let's understand a situation. Problem understanding. Here, a company is producing something, a component, in which a chemical has to be coated, right? Some coating process is happening. And the coating thickness required is 50 microns. Coating thickness required is 50 microns, plus or minus 3 microns is okay. Now, what is your upper spec here? 53. Lower spec?
47.
47. Now, the raw material is coming in the form of a big roll. You all know, sheet metal rolled in a big roll. Now, once you load a particular roll, thousands of pieces are produced. Thousands of pieces are produced. Now, you have to coat the roll and then cut it into pieces. Every piece is expected to have exactly 50 micron plus or minus 3 as the coating thickness. Now, this is what is going on. Now, you are the plant head. Now, what is important to you? The overall capability is important. You know, once the first roll is finished, your people will load the second roll. Once the second roll is finished, they will load the third roll. It keeps going. Now, in order to understand the overall capability, what do? You take sample from every single roll. Am I correct?
Yes, sir.
If your sample comes from only roll number 1, then you understand only within capability. The capability within roll number 1. But if you take sample covering all the rolls, now you are able to understand overall capability. That is the reason why, as a plant head, you advise them to, your quality managers, to collect 3 random samples from every single roll. Every single roll, 3 samples are taken. If you take samples together, multiple samples together, that is known as subgroup. Now, this is first subgroup, this 3. So, subgroup size is 3. Subgroup size is 3. First subgroup, second subgroup, it keeps going, and there are 25 subgroup. Each subgroup, 3 data point. So, totally there are 75 data point. With the 75 data, you need to calculate CpCpk, you need to calculate PpPpk. Now, if you use the data in a particular manner, you get CpCpk. If you use the data in a different manner, you will get PpPpk. But the data is common. All of you are with me? Now, there is within capability and there is overall capability. Let's see how the calculation goes. Number of subgroups is equal to number of roles, 25. So, subgroup size, the number of data in each subgroup, 3. So, total number of data, 75. Now, if we use all the 75 data and measure the variation, that will be overall variation, right? And another variation is within variation. In order to you calculate the within variation, the formula is R bar by D2. Now see here, every subgroup, please calculate the range. You know maximum minus minimum is the formula. For first subgroup, what is maximum here? There are 3 data points. Maximum is 50.4. Minimum is 50.1. And the difference is R1. In this manner, you have to come up to R25. See here, you have R1, R2, R25. After calculating 25 ranges, what you need to calculate is, you need to calculate R bar. What is R bar?
Mean of range.
Mean of ranges. So R1, R2, etc., R25 and divided by 25. That is known as R bar. Afterwards, to convert the range into an appropriate standard deviation, because we know we always need variation in terms of standard deviation. The formula is R bar divided by D2. And the D2 is a statistical constant that depends on subgroup size. You see here, for a subgroup size of 5, the D2 value is how much? 2.326. You can use this formula and you can calculate the equivalent standard deviation. And standard deviation is 0.4139. This is known as within standard deviation. How many of you understand how to calculate within standard deviation? 25 groups, and from each group range is calculated, and the range is centered by calculating R bar, and then R bar is converted into sigma by using the formula R bar by D2. Now this sigma is within sigma or within standard deviation. If you use this standard deviation and use it in your formula, that will give you CP and CPK. Clear, all of you? Now within is calculated, CP is found to be 2.46, CPK is 2.37. Now what is your conclusion? Process is capable?
Very capable.
Doubly capable, above 6 sigma. Please note, this is true in short term. This is true in short term. But I am concerned about the long term. If my process goes on in the same manner, will there be rejections happening? Or will it, right now, I don't see any rejection because it is 2.37. There is no rejection, right? But in long run, what will happen? For that, you need to calculate overall standard deviation. What is overall standard deviation? Totally, how many data points you have?
75.
Can you use all 75 data and calculate a standard deviation out of it? Possible?
Yeah.
That is known as overall standard deviation. In Excel, type all 75 data in a single column and then calculate the standard deviation. Look at that standard deviation. How much it is?
0.83.
And compare this value with your within standard deviation. Almost
Double.
That means what you see today and what you are going to see in the future, there is going to be a big difference.
Variation increased.
You are predicting the future by looking at the sigma of today's data. Right? And now with using this sigma as a standard deviation, I apply in my PpPpk and my PpPpk are 1.19 and 1.15. Now I am not meeting the requirement because the requirement is always 1.67. You remember your customer has told you every 1 hour PpPpk must be 1.66, but we are getting only 1.19. Under this condition, customer may not sign the work contract with you. All of you understand? So now, this is the table and this is the report. The dotted line indicates your current performance, but the red color curve indicates your future performance. Current performance, everything is inside the specification. But future performance, there is a tendency to cross LSL. Because your process is slightly shifted to the left and there is a tendency. Right now, there are no rejection. You see zero rejection. Zero rejection. But some rejections expected, you can see here, 0.04. Right? Percentage of out of spec expected is 0.04. In terms of percentage, 0.04% only, very small. But then, if you produce 1 million pieces, I don't know whether 0.04% is tolerable or not. Right? So that's the indication. CpCpk sounds good, but PpPpk is sounding bad. That means this capability is okay if you are looking at producing some small numbers, no problem. But the same capability is not sufficient if you are looking at producing some big numbers. But what is small and big, you have to define. All of you understand? Producing just 500 pieces and supply and sending and dispatching it, it's not a big deal. But producing 5 million pieces or 5,000 pieces, 50,000 pieces, it may be, a long-term requirement. And now that may demand a higher PP and PPK. All right. So this is the actual performance indicated by the red curve, but this is the potential performance or short-term performance, CpCpk. So the same thing is put in the mini tab, and I will also put it one more time for your better understanding. And this is the report generated. You see here, PpPpk 1.19 and 1.15, same value. Hereafter, whenever you see CpCpk, don't blindly read it. What is written above you? Please look at. What is written here? BW capability. What is BW means?
Between capability.
Between within.
Between
Between within.
within.
between within. That means it is combination of your within and between. When I combine within and between, my CpCpk is this much. But normally, people look at overall, people look at within, that's all. They don't look at between, they don't look at between within. But if you know what is within and what is between, you also know what is overall, then you can look at anything and then you can try to understand. For example, in our problem, role-wise components are produced, right? Do you know what is within capability? What is within capability? Are we maintaining quality consistently within every single role? Isn't it? Overall capability means, are we maintaining the quality on the whole, irrespective of the number of roles, irrespective of the changes in the roles? Am I able to maintain the same consistency in the quality? Now, suppose I want to understand the between capability. Tell me, is there a way I can understand the between capability? Can somebody talk on this? Within is understood, overall is understood. I want to understand between. Tell me, is there a way to understand between?
I calculate two within processes and compare it.
Very good. Let me give some explanation here. See here, for the first subgroup, how many data you have? 3. Can you find out the center point here? Can you find out average? Can you find out an average for the first 3? Am I audible?
Yes, yes.
Yeah.
Yes, sir. 50.3.
First subgroup average. Similarly, I want you to calculate second subgroup average. I want you to calculate third subgroup average. If the averages are close to each other, the between capability is better. Are you getting me?
Yes, sir.
If the range is small in first subgroup, same amount of, same level of range in the second subgroup, that means, within capability is good. So within capability, we use the range. Between capability, we use the average. If I can combine, then I get within, between within, right? But let us not complicate our understanding. Let's only limit our thinking to within and then overall, right? So we have seen this. We've seen this graph also. So yeah, this graph also we have understood. Now tell me, and look at the things here. First thing to understand is, see here, as of now, when I consider the observation, there are no rejection. But when I consider the overall, can you see some rejection of 394 units? Can you see 394 here?
Correct. Yes.
That means even though there are absolutely 0 rejections in your study, it doesn't mean that you won't get any rejection in the future. In the future, you might get rejection. And how much it is expected according to the data? 394. Out of the 394, almost 293 are happening beyond LSL on the left side, because your process is slightly shifted, right? That's the thing. See here, your overall standard deviation available, within standard deviation available. This is what we manually calculated. Same manner, there are methods by which you can calculate this also, you can calculate this also, and accordingly you can describe different capabilities, but then do them one by one while when you are actually coming across a practical scenario, right? Otherwise, you might find it too theoretical, and then you will find it difficult to understand. Let's not do that. So when you actually work on a project, yes, we can handhold you better. So whenever process is statistically out of control, my suggestion is better don't conduct capability analysis. If at all you are forced to conduct the capability analysis, look for a healthier PpPpk. Look for a healthier PpPpk. But if the process is out of control and you also look at the CpCpk, then in the long run, you will be far, far away from what you have studied. Do you get my point? Ultimately, why we use statistics? We want to predict what will happen in the future, right? So that our decision should reflect the reality. So now tell me, I'm showing you a process. Is this process under control or out of control?
Out of control, sir.
Out of control. Under this condition, is it a good idea to conduct capability study or we should not conduct?
We should not, sir.
We should not.
But then tomorrow customer is coming for an audit and they have asked for the report. Now you can't escape. You know it is not advisable to do the capability analysis, but customer is coming for an audit, so your boss wants the report. Now, how will you manage the situation? Normally, what we do, we tend to remove all the red color points, isn't it?
Yes.
We remove all the red color point and then we calculate. So when you do that such things, please at least add on some assumptions. What are the assumptions? The study is conducted so-and-so period and data collected in subgroup with a subgroup size of 10 and data is collected over a period of week and the process is assumed to be under statistical control. If you include all of this, whatever you have written is correct. You are passing on a realistic information to other person. Isn't it? If you don't write assumption, you are actually passing on a false information. Am I correct?
Sir, even then the questions will arise, right? If you're saying the process is statistically under control, how come there are so many, red marks or deviations or something like that? So
That's
just
what you
because
don't show.
I am assuming doesn't mean that it is correct, right?
No. See, in capability study, if you remove the red color point, the curve will not look like this. All right. See, if you remove all in real time, we all are supposed to do what is required by the company. Yes or no? You have to prepare the report because there is an audit and you have to do it. So it is actually, it is not a good piece of advice to work in this manner. But then to face the scenario, we are doing it. So you not necessarily, it is not necessary that you show the control chart in the as it is condition. No. In the assumed condition, the red color points will not be there. Right? And moreover, your capability report will only look like this. It will not have any control chart. Can you see here? Where is the control chart here? But we only know what happened in the background. And we are adding it in a very diplomatic manner. We are writing some assumption here. But if the other person who is reading your assumption, if he could make out what you have done, then you will be in trouble. Right? And that's why, see, in many companies, they just use all these tools without probably having a proper understanding sometimes. For example, the PpPpk, the PpPpk, they use it interchangeably. Wherever it should be called as CpCpk, they call it PpPpk. Wherever it should be called as PpPpk, they call it CpCpk. So under such confusion, yes, you will be safe. But if the other person is also equally sound, then he may ask a lot of questions. But see, the practical scenarios, I hope you all are better than us to handle. You have been handling it for years together. So I only wanted you to be correct in your report. And for that only I suggested to add. But if you think adding the assumption will damage your position, then you may do whatever is appropriate.
Sir,
Right.
in fact, last week we had looked at something called Nelson's test, wherein let's say we remove all these red spots, the line would actually beat around the mean, and 15 points within tightly bound within the mean will also increase fake or fudge data. That was one of the inferences suggested by Nelson's test. So, yeah.
Correct. That is, see, if someone looks at your process, they should not be able to make even a single comment. That's called normal performance. Normal means nobody finds even a single chance to comment about our process. How the process is performing, and it's just performing normally. And everything is happening on its own according to the process. We can't judge anything. Any kind of pattern, cyclic nature, if that appears, they're all special causes. Special causes not only means seeing points outside the control limit. Sometimes special causes you will be able to detect even if all the points are inside the control limit. Say, for example, how many people are attending the meeting right now? How many people are attending? If you look at the participant list, you come to know, right? How many? It is showing 26. Yes or no?
Yes, yes.
Yep.
But few of the participants are absent today. They are also part of the training program, but they are absent. That means your points are out of control. Am I right?
Yes.
Your process is definitely out of control. There are some failures expected, definitely. Some action is required. So if points are appearing outside the control limit, it's a clear indication of out of control. On the other hand, if all the points are inside the control limit, it doesn't always mean that your process is under control. See, there are 25 participants inside the meeting. Is that all of them are really paying attention to me? I have a doubt, isn't it?
Yes.
Some people are attending, 2-3 training program at a time. They keep 3 laptops. In one laptop, Six Sigma black belt. In other laptop, something else, Scrum Master. In another laptop, one more training. So even though your points are inside the control limit, if I could see some kind of pattern, some kind of cyclic repetition of something, trend, these are all indication that your process can still be under the influence of something and failures can happen. So that is what you have studied, with those some additional rules. But you will be able to better understand the trend, pattern and cyclic behavior if you have enough experience about the process. If you are matured enough, you will be able to detect special causes even if all the points are inside the control limit, right? Otherwise, you might simply think, everything is going well. So we are in the field for several years together. So we know how participants will be attending the training program from the other side, right? So we need to judge accordingly. So here clearly process is statistically out of control and capability analysis is not recommended. If you still conduct the capability analysis, look for a better PpPpk and don't settle with better CpCpk because PpPpk is a better estimate, right, than CpCpk. But within CpCpk, CpK is a better estimate than Cp. Hope all of you understand how to use the tools. The tools are for effective decision making, nothing else. Also, whether you calculate CpCpk or you calculate PpPpk, please note all of them are estimates. To the best of your ability, you have calculated something, you have estimated something. Just because you calculated PpPpk of 2.22, it doesn't mean that the exact capability is 2.22. No. It is an estimated value. Yes or no?
Yes.
Know your limitation always. And this is called, like uncertainty in your decision. The uncertainty in your decision can be minimized by keeping your data sufficient enough, by keeping your data more and more accurate. Clear? That's all about CpCpk and PpPpk. And now I will open Minitab to show you how the same thing will work in Minitab. And meanwhile, RK might share a few important points.
Yeah. Points. I have lots of points, right? Only thing is, points will become ocean, no? Lots of it. Then they'll get confused. Tell me, drops are
Yeah.
okay or the ocean is okay? Drops are okay. We can drink, right? Ocean water we cannot drink. Now tell me, Cp CP is okay or CPK is okay or both are okay?
CPK is
CPK
better than
PPK is okay.
CPK is what you should see to find out the performance. Now, if CPK is greater than 1.67, the process is excellent. Yes or no?
Yes.
Very good. If the CPK is less than 1.3, it is very poor, incapable. Yes or no?
Yes.
If it is between 1.3 and 1.67, fair. Yes or no? Yes.
Capable, yeah.
That's all. Now, CPK measures the location of the target. Yes or no? If CPK finds that the target is located centrally, then the value of CPK will be equal to CP. Yes or no?
Yes.
Right? Very good. What else I can say? I will use this jargon. No, he has not used it. The instantaneous capability is measured by CPCPK. Yes or no?
Short term, yes.
Very good. The consistent performance of the process is measured by PpPpk. Yes or no?
Yes.
That's
Yes.
all. You know everything about CPCPK, PpPpk. What is C stands for in CP?
Capability. Capability.
Capability. What is P stands for in PP?
Performance.
Performance.
What is small p stands for in CP and PP?
Process.
Very good. That's all. What is K stands for in CPK?
Index.
Index.
Very good. That's all. You know everything. What more you want? Congratulations, Gopal Shivkumar.
Thank you.
It has gone thoroughly into them.
Very good, very good. So hope you people have understood the difference. And what's more important is your ability to use the tools, CPCPK as well as PpPpk. So always try to ensure you have sufficient data and you have accurate data, right? If there is a problem with sufficiency, if there is a problem with accuracy, you should know, to a certain extent, you should know its limitation. Accordingly, you can use the data. Now, let me show you how can you calculate the CPCPK as well as PpPpk using Minitab. So same problem. I've shared the Excel file with all of you. Hope all of you have got this Excel with you. I'm looking for the coating thickness. So a lot of work I have done in this sheet. Please explore some calculus here. You see here, all of you, can you see coating thickness? One sheet having coating thickness, the same data that I have used for explaining the concept. Can you see 75 data points?
Yes.
Very good. Now, with all the 75 data points, I can calculate, see here, I can calculate, what is this? Average. And I can also calculate standard deviation, right? How can I calculate standard deviation? It's very simple. Standard dev dot s. Starting from here, I should go up to this. Sorry. That's all. Close the bracket. Can you see your overall standard deviation? In no time, it is calculated. All right. Similarly, some calculations here. Data, subgroup number, subgroup average, subgroup range. Can you see all 25 ranges here in this column? Column H. Subgroup ranges. How to calculate within standard deviation? R bar divided by D2. What is R bar? Here it is.
Sum of all the subgroups.
Average of all the subgroup ranges. Can you see the formula here, right? All the 25 ranges, I have taken average. And then I divided that one divided by D2. I have to divide that value by D2. And that will give me within standard deviation. You see here, what is the formula? H is 77. What is H is 77? 0.700816 divided by 1.693. What is 1.693? Statistical constant. So within standard deviation available, overall standard deviation available. Accordingly, PpPpk and CPCPK are calculated. Now let us see how can we do it. Sorry, how can we do it in
Sir,
Minitab?
can you show the statistical constant for 1.6? from that table once.
Okay. That is there in the material itself. See, I have given one manual also to all of you, training manual. There also you can find it. Yeah, this is here is the table. Are you able to see the table?
Yeah. Where is this one? D2. D2.
What is your subgroup size? Subgroup size is 5, right? 5 or 3? 3.
3. 3. Okay, okay.
And what is
Okay.
T2? 0.69.
Okay. Okay.
Got it.
Thank you.
Yeah. So now that I'm taking you to Minitab, I'm placing my cursor on the gray bar and pasting. Now, what is that you are seeing? The same problem, right? Coating thickness. Can you see the coating thickness, all of you?
Yes.
All right. So
Yes,
now
sir.
we need to do the capability study. Go to Stat, go to Quality Tools, and there is capability analysis for normal data. Now, data in single column. Yes, that is column number 1. Click select. Now, subgroup size, you all know subgroup size is 3. What is your lower spec? Coating thickness, lower spec.
48, sir.
47.
47. Upper spec 53.
53.
Now, you don't have to do anything here. Now you give OK. Can you see your capability analysis report? Now you can right click. You can send it to your PowerPoint. You can present it. Right click, send the graph to PowerPoint. I have sent it to PowerPoint and now you can see the same graph in my slide. The last slide it will have. Let me check. Can you see an additional slide in my PowerPoint presentation after thank you?
Yes. Yes.
So it's so quick. You can generate your graphs and then you can do that. So now I'm taking you to the mini tab again. Where is it? It's here. So you all now understood how to conduct the capability analysis, right? Only what is the requirement? Your data must be continuous for PpPpk calculation. Now, if I want to plot a control chart for this, because always prior to capability analysis, we should check whether our process is under statistical control. Which control chart I can use now? The type of control chart depends on type of data. What is your data type?
Data type is continuous, subgroup is 3. So it
X
is
bar R
actually
chart,
X
sir.
bar,
X bar R
X bar
chart.
R chart we can use.
Very good. The type of control chart is X bar R chart. When the subgroup size is more than 8, you can go for
X bar S chart.
S chart. When subgroup size is just 1, you go for
IMR.
R chart. Very good. So stat, control chart, variable chart for subgroup, X bar R. Now, all observation are in one column. That column is C1. Now X bar observation for a subgroup are in one row, not one row. Let me check. One column. All right, one column. All the data in one column. So click, double click, subgroup size 3. Now X bar R option. Now there are several tests possible. You see here, so many tests. Whichever you want to test, you can test. But I am putting only one condition, whether I'm only checking whether my points are outside the control limit or inside the control limit. And location for control limit is 3 standard deviation, 3. Okay. One more okay. What is the condition now?
Process is statistically out of control.
But so all the conclusion what we are done, what we have conclusion we have drawn can be misleading conclusions. All of you understand?
Yes, sir.
So we shouldn't have done that because all simply we'll see when there are so many out of control points, the predictability will be poor. If predictability is poor, how can you believe your statistics? So that's the limitation. And one more thing, the data must be normal. Whatever data you use, that should be normal. You can check normality also by plotting a graph. What is the graph you can use to check the normality? It is in the list of 7QC tool, histogram. The purpose of histogram is to understand the distribution, how your data is distributed. You can use simple or you can use the one with the fit. Okay. And select this, give okay. And now tell me, is your data looking normal? Looking normal or not?
Yes,
Yes,
sir,
sir,
it
it is
looks
skewed
normal.
Yes, sir.
Normal.
Normal.
It is
Very
a
good.
normal symmetric data.
Yeah. When you expect normality, it won't be a perfect normal. That's difficult, right? And none of you can be a perfect gentleman always. No. Right? Same manner, your data, more or less normal is fine. But if you find it difficult to understand the normality with just eye judgment, you can conduct a normality test also. Hope you know, right? Basic statistics, and then there is a normality test. And variable is coating thickness. And the test is Anderson-Darling. Okay. And how much is your p-value? More than
0.26.
286.
Yeah.
more than
0.286.
0.05. Since it is more than 0.05, your data is normal. Null is accepted. Null cannot be rejected now. Alternate way of running the normality test is basic stat, graphical summary, coating thickness. Now, both will happen simultaneously. Histogram also will come. P-value will also come. You see here, histogram has come. Your P-value has come. So, all of them confirming the normality, but process statistically out of control, and you still have a PpPpk and PpPpk in your hand. You are the best judge now. What to do with your report? I leave it to you. All of you understand what I'm speaking? You have the report PpPpk, but your data is normal, no problem there. But your process is statistically out of control. There is a problem there. So that's it about CpCpk as well as PpPpk. Any questions? I'm open to it. Otherwise, we are ready to move on to the next stage.